Okay, let's talk about problem one from mechanics part one, or from mechanics. And this is basically a statics problem, right? We're interested in a couple things. We're interested in the forces, like this is the vertical component of the tension from the muscle. That's the horizontal component. This is the force on the elbow or on the shoulder, pardon me, right? And its components. We're interested in a couple of things. One, we want all the forces to balance, right? All the forces have to be balanced. If they're not balanced, then this is moving. And we also want all of the torques, the torques being, tau, all the torques to balance. What does that mean in the context of this? Well, we're going to put the pivot point right here at the shoulder. That mathematically makes sense because then that eliminates F as an unknown. And we're going to look at balancing the pivot, the torque around that pivot point, which is due to the vertical component of the tension T here, trying to make it rotate that way, and the weight of the arm trying to make it rotate that way. Right? So we're gonna have our forces balance, we're gonna have our torques balance, and you can see right now from the torque equation that the T sine theta is gonna be times L1 is gonna be equal to W times L2. And so you immediately get T out of this um, because let's see, what do we have? We know yeah, we know the angle, we know the weight, we know L1, we know L2. The only thing we don't know in the torque equation is T. And so we get T out of that, right? And that's what it's asking for. What is the tension in the deltoid muscle? T. So this piece, this first step is actually pretty straightforward. Um, so we want Fx equal to 0, the y components all equal to 0, the torque equal to 0, and as I mentioned above, when we put the torque equation together, Ty, which is T sine theta, L1 minus L2W is 0, so we get Ty is that, and we get out of that the equation for T. So on this first problem, we're set. We know that the tension on the deltoid muscle is given by this relationship with the weight. And you can see as you shorten the distance that the muscle attachment is from the shoulder, the tension has to go up, and as you make it longer, it goes down. Um, the longer your arm, the higher the tension goes. The shorter your arm, the lower the tension is. And then that angle also makes a fair difference as well. All right, that's it for problem one. Good luck with it.